Alright, so we are going to start the unit on solutions. A lot of this information you have already semi-heard before, but we're going to go a little bit more in depth. So first of all, let's talk about a couple of the vocab words that you should already know. So first of all, soluble. Soluble means that it is capable of being dissolved. So for instance, you can dissolve sugar in water, you can dissolve salt in water, but oil does not dissolve in water, so oil is not soluble. Another one that you should know is homogeneous mixture, and that means that it is the same throughout. So the example I like to use is vanilla ice cream. Another word is heterogeneous mixture. This means that it is not uniform throughout, so you can clearly see differences throughout it, such as Rocky Road ice cream. You can see the marshmallows, you can see the nuts, you can see the fudge made throughout it. And then last but not least is solution. This is a homogeneous mixture, which means you cannot see a difference of two or more substances in a single phase. And all a single phase means it all looks like the same. So when you dissolve salt in water, you can no longer see the salt. All it looks like is water to you. It's still clear, you can still see through it, so it's in the single phase. If you dissolve sugar in water, again, it's still clear, it looks just like water, so it's in a single phase. Air around you is in a single phase. You can't see all the different types of gases in the air around you. Okay. So now let's talk about some of the components of solutions. So first of all, we have a solute. This is what is being dissolved. Usually this is the item that is lesser in quantity. Not always, but usually. Next is solvent. This is what the solute is being dissolved into. Usually solute particles are so small they cannot be filtered out. So this is what makes it a solution, again, in a single phase. If you take your salt water, you can't just filter it out to get your salt back. You have to use the process of distillation, which hopefully you guys remember what that is. So for example, if we make sweet tea, you are going to dissolve the sugar into the tea, so therefore the tea is the solvent because it is doing the dissolving of the solute, which is sugar. Okay, so let's go over some of these different types of solutions. Okay, and I'm going to talk about each one of these individually because you will have some of these on your test as examples. So a lot of times people think of solutions just as liquids, but there can actually exist in gas, liquid, or solid form. So an example of a gas dissolved in a gas is oxygen dissolved in nitrogen. Another one of gas dissolved in a liquid is CO2 dissolved in H2O. This is in your water supply around you. This is soda. You have carbon dioxide dissolved in the soda that you drink. That's what makes it fizzy. You can also have a liquid dissolved in a gas. This is the one that's often overlooked. For instance, water is dissolved in the air. We have water vapor in the air around you all the time. You can also have a liquid dissolved in a liquid. For instance, alcohol in water. Usually liquid dissolved in liquid is really hard to be able to tell that you have two items there. You can also have a liquid dissolved in a solid, such as mercury in silver and tins. This is what your dental fillings are made out of. You can have a solid dissolved in a liquid, for instance, sugar and water, just like the sweet tea example I just gave you. And last but not least, you can have a solid dissolved in a solid. And the example I came up with is copper dissolved in nickel, which is commonly found in alloys, etc. Alright, so let's talk about what a suspension is. So we've kind of reviewed solutions, but suspensions might be a little bit new. This is particles in a solvent are so large they settle out unless they are constantly agitated. So when you mix two or more things together and you have stuff settle to the bottom or float to the top, this is usually a suspension. They can be filtered out. The size of these particles is usually bigger than 1,000 nanometers, which is much, much, much bigger than that of atoms. An example I like to give is muddy water. If you take a glass of muddy water and let it sit there for a while, eventually the mud will settle down to the bottom and you'll be left with clear water towards the top. The next thing I want to talk about is something called a colloid. These particles are bigger than that of solutions, however they are smaller than that of suspensions, so they're somewhat in the middle. The size of these particles is somewhere between 1 nanometer and 1,000 nanometers, and these can pass through a filter. So these are actually really hard to separate because you can't filter out the particles like you could in the suspension. Okay, they're going to filter they're going to pass through the filter and they're still going to be there. So for instance, again, if you have muddy water, you can filter out the big pieces of mud, you can filter out the rocks, but it's really hard to get clear water without using a different process because colloids have really small particles in them. Now I'm going to talk about something called the Tyndall effect. This deals with colloids. Some colloids appear to be homogeneous in solution. So when you just first glance at them, they look like they're a solution. It doesn't look like you can see anything floating in there. However, but when you shine light through it, there are particles in there that will scatter light. And this is what tells you that it's a colloid, and this is actually called the Tyndall effect. This occurs when light is scattered by the little particles in a colloid. The easiest example that I can tell you about this one is you guys have all been sitting on your couch at home watching TV or doing whatever, and the sun starts shining in the window, and all of a sudden you can see all these dust particles and whatever floating in the air. You couldn't see them beforehand, so it didn't bother you. You didn't even notice that they were there. But as soon as the sunlight starts to shine in through the window, you start to see these little particles, and that's how you know that the air around you is actually a colloid and not a solution. Alright, so when we're talking about solutes, remember solutes are what are being dissolved into your solvent. So like in the sugar water, this would have been the sugar. In the salt water, this is what would have been the salt. We also have two different things that I like to talk about. We have something called an electrolyte, and I'm not talking about electrolytes in Gatorade. Okay, an electrolyte is a substance that dissolves in water in order for the solution to conduct an electric current. So examples of things that are electrolytes are any soluble ionic compound, so any ionic compound that can dissolve in water, such as salt or hydrochloric acid. There's also a non-electrolyte. This is a substance that contains neutral solutes, which means, yes, it can be dissolved in water. However, usually they are neutral, which means you have to have covalent compounds, and they do not conduct electricity, so this would be like sugar. So usually if you have an ionic compound, you're going to have an electrolyte. Usually if you have a covalent or a molecular compound, you're going to have a non-electrolyte because ions conduct electricity and things that are not ions do not conduct electricity. So summary, which is largest, a colloid or a suspension? Yay, a suspension. When a mixture is not uniform throughout, we refer to it as what? Hopefully you guys are all thinking heterogeneous mixture. What effects takes place when light particles are scattered off of colloids? Again, like when you were sitting on your couch and the sun started shining through the window. Hopefully you guys are all thinking of the Tyndall effect. Okay, true or false? Can electrolytes conduct electricity? Okay, remember electrolytes are ionic compounds, which means they are made out of ions, so this should be true. Colloids are larger than 1,000 nanometers. Is that true or false? Right. Colloids are actually the one that are in the middle, so this is false. This would be a suspension, not a colloid. Colloids are smaller than 1,000 nanometers. Okay, true or false? Sugar water is an example of a liquid dissolved into a solid. Okay, well, sugar water, usually you're going to dissolve sugar into your water. Usually you're going to have more water than sugar. So therefore, sugar is going to be your solid dissolving into water, which is your liquid. So this is an example of a solid being dissolved into a liquid. So false.